and it's time to deploy things to production. Since I already have a service deployed, I won't trigger a new deployment, but I'll show you the Kubernetes YAML manifest files that you'll need to apply for a similar deployment setup, which I think is enough information to deploy the code to a cluster anyway. So this is our ingress, which manages an AWS application load balancer or ALB behind the scenes using these custom annotations. And for the interested, you can always check out the lecture notes on this video's webpage for more information about Kubernetes ingress controller with AWS ALB. So we have two hosts, FizzBuzz Pro and www.fizzbuzz Pro, and both of them point to a service named web on the TCP port 80 with a default route as a path prefix. For these routes to work, we need to define this web service, and also we need a web deployment that manages one or more pods that this web service will be using. So let's create those as well. This is our web service. It will listen on a target port 8888, which is the TCP port that our container is exposing its service at, and it will serve at standard TCP HTTP port 80. And type cluster IP means that our service is internal to the cluster only, so without an ingress controller, it is impossible to reach our service from the outside world. We define certain environment variables as config maps and secrets, where we are going to inject all of them to our Fizz web deployment object as well. So let's create our deployment and see how we can add these environment variables into it as well. Our deployment is under Fizz namespace and it manages a single pod, which we can add more if we wanted by increasing this replica count. The pods that our deployment manages should have app equals web as their label selector, and the pods that our deployment creates also has an app equals web as a label selector. And we reference our Fizz web container with a tag that we recently published. And we have some default resource limitations on this template, and we are exposing port 8888 on our pod as well. And these are the environment variables that we inject to our pod from config maps and secrets. And once we do a kubectl apply-f dot, we can deploy our brand new application to our cluster, which I am not going to do, as I said, since I already have a running deployment and I don't want to jinx it. Instead, I'll show some of the deployed resources in the cluster. When we do a kubectl get ingress, we can see our ingress that's serving these two hosts. Kubectl get service will show some information about our web service. Kubectl get deployment will show info about the web deployment that we have. Kubectl get config map and kubectl get secret will show our cluster's config maps and secrets respectively. And finally, kubectl get po will display that we have a healthy web pod up and running. Finally, here is a high-level diagram of our entire deployment, which also concludes our demo. In this series of lectures, we created a full-blown web application with static content generation, user authentication, payment gateway integration, and a bunch of other stuff, and deployed it to our Kubernetes cluster in around half an hour, which is great, I guess. In the upcoming lectures, we'll circle back to this app and we'll add more features to it. But as far as rapid prototyping a full-blown production-ready application goes, that's all there is to it. Until next time, may the source be with you.